so y'all go ahead and do your factoring and math knowledge question for today. Pause the video, and then whenever everyone is finished, y'all go ahead and play it, and I'll show you the correct answers. So 98 and 200 both have a 2 in common, so you're going to start by factoring that out, and you're going to be left with 49x squared minus 100. And then 49x squared minus 100 is just a difference of 2 squares. So that'll factor as 7x minus 10, and then 7x plus 10. And so this is how it should factor. For the math knowledge question, we are looking for the perimeter of a circle. So our circle has a radius of 4, and for perimeter, that's your circumference. And for a circle, your circumference is 2 pi r squared. So if you plug in a 4 for your radius, you're going to end up with 8 pi, which it says to round to the closest number in feet. So 8 pi is approximately 25.13. So the closest answer to that is 25 feet for your perimeter there. We are looking at lesson 64 today. We're dealing with derivatives of inverse trig functions, and then I'm going to go over what to memorize. There are 6 inverse trig functions that hopefully you will understand after this lesson, and then I'm going to go over the ones that you need to memorize. You don't need to memorize all 6 of them. There are only going to be 2 of them that you'll have to memorize. So the first derivative for the inverse trig functions that we're going to look at is sine inverse. This sine inverse right here, this is the same thing as arc sine. So sometimes they'll write it as arc sine, sometimes they'll write it as sine inverse. But the sine inverse of x over a equals your dx over the square root of a squared minus x squared. Now they may write it like this. The derivative of sine inverse of x over a is just 1 over the square root of a squared minus x squared. So you may see it written like that. Y'all need to go ahead and write that one down for your notes. This is for the cosine inverse, the derivative of cosine inverse. Notice that the only difference between arc sine and arc cosine, we've got a positive dx here, and we have a negative dx for our cosine inverse. The denominators are the exact same. The only difference is that numerator. Next, we have tangent inverse. The derivative for tangent inverse of x over a is a dx over a squared plus x squared. Now again, they may write it like this sometimes, where you just have a over a squared plus x squared. So you need to be familiar with both forms, where it has an a in the numerator and where it has an a dx in the numerator. It's just whether it's found in the differential or the derivative. That's the only difference there. And then for the derivative of cotangent inverse, again, if you'll notice, it's very similar to tangent inverse. You've got an a dx in your numerator, and over here you have a negative a dx. So the only difference is that negative sign. Everything else is the same. And then moving on to secant inverse of x over a, the derivative of that is a dx over x times the square root of x squared minus a squared. And then for cosecant inverse, the derivative for it is very similar to the derivative for secant inverse. You're just looking at a slightly different numerator. The only difference there being that one of them has a negative a dx and one of them has a positive a dx. So those are the 6 derivatives of inverse trig functions. And so we are going to look at some examples using those. So the first thing that we're going to do is draw the triangle that is given by this right here. And so it looks like a right triangle because that's what we use whenever we have sine, cosine, and tangent. Now, y equals sine inverse, because arc sine and sine inverse are the same thing. Y equals sine inverse of x over a. We can rewrite that as the sine of angle y equals x over a. And so your angle is y, so I'm going to put it down here at the bottom left. You can put it here at the top if you want, it doesn't really matter. But if this angle is y, the sine of this angle is x over a, your opposite over your hypotenuse. And then, in terms of a and x, this side here would be the square root of a squared minus x squared, using your Pythagorean theorem. And so that is the triangle that we're going to use in order to find the derivative here. So we are going to take the derivative of this equation here, the sine y equals x over a. The derivative of sine is cosine. And we're actually going to take the differential, so we're going to have a dy because our variable is a y. And then the derivative of x over a. X is the variable, a is just some number. So we really have 1 over a x, and so the derivative, the 1 over a stays, the x goes to a 1, and then we took the derivative with respect to x. So really you're just taking the derivative of x, which is 1 dx, and then the 1 over a is just some random number there. And so that would be your differential, and so now we solve it for dy over dx. So if you divide by dx, you get the cosine of y, dy over dx, equals 1 over a, and then we need to get rid of the cosine of y. So divide by the cosine of y. And I'm going to actually multiply by 1 over cosine of y. And so my dy over dx equals 1 over a times the cosine of y. But what we want to do is figure out what is the cosine of y. So let's look back over here at our triangle. The cosine of y, well, that's adjacent over the hypotenuse. Our adjacent is the square root of a squared minus x squared over the hypotenuse of a. So in our equation over here, we can say 1 over a times, and instead of the cosine of y, we can actually say the square root of a squared minus x squared over a, just by substituting that in. And then if you look, these a's will cancel, and so we have 1 over the square root of a squared minus x squared. And so this is what your derivative is, right here. And so that's actually how you derive it, how you get to that formula that I showed you just a minute ago. Okay, looking at the next one. We're going to show how to get the derivative of arc cosine of x over a. So again, we're going to use a triangle. We're going to make a right triangle here. And we need to make y equals cosine inverse of x over a so that it's a cosine. And our angle is going to be y, and the cosine of angle y is going to equal x over a. So again, I'm going to put my angle here, but this time the x is my adjacent and the a is the hypotenuse because we're dealing with cosine. This side right here is going to be the square root of a squared minus x squared from Pythagorean theorem. And so now we're going to do just like we did last time. The derivative of cosine here is going to be negative sine y. And we're taking a differential, so we're going to put a dy. And then the derivative of this. Again, this is the same thing as 1 over a x, which the derivative of a number, 1 over a, is just 1 over a. And the differential of x is 1 dx. So we have dx here. So to solve for dy over dx, we got to divide by dx. So I have negative sine y, dy over dx equals 1 over a. And then we divide by negative sine y. So I'm going to multiply by 1 over negative sine y. And so I end up with 1 over negative a times the sine of y. So again, we need to look back at our triangle and figure out what the sine of y could be. So if you look over here, the sine of this angle is going to be opposite, which is the square root of a squared minus x squared all over the hypotenuse a. And we can plug that into our equation down here. So we're going to have 1 over negative a times, instead of y, the square root of a squared minus x squared all over a. And so these two a's cancel, and we have 1 over negative square root of a squared minus x squared, which looks pretty close to what we have written. You can write it like this, negative 1 over the square root of a squared minus x squared. And now your derivative is almost exactly what we had written on the board just a minute ago for that formula. So that would be to find the derivative of an arc cosine. So now we're going to do the same thing for a tangent. All right, so again, we're going to draw a right triangle. And we need to take y equals tangent inverse of x over a and rewrite it as the tangent of angle y equals x over a. So our angle is y here. The tangent is x over a. So it's opposite over adjacent, x over a. Notice that every time we've used an angle y, but the placement for the x and the a have changed, depending on if we're dealing with sine, cosine, or tangent. So our angle's always been y, but the x and the a change depending on what trig function you have. So the hypotenuse is going to be the square root of a squared plus x squared. So the derivative of tangent, that's one that you're supposed to have memorized. Some of you have, some of you have not, but the derivative of tangent is secant squared. And since we're taking the differential, we're going to put a dy there. And then just like on the last two, the derivative of x over a is going to be 1 over a and dx, because we took the derivative with respect to x. So now we need to find our dy over dx. So we divide by dx, and I have the secant squared y, dy over dx equals 1 over a. And so now we are going to divide by secant squared. And so we have dy over dx equals 1 over a times 1 over secant squared y. So at this point, there are two ways you can do it. You can either leave it with the secant squared y, or you can make it 1 over a times the reciprocal of secant would be cosine. And so you can make it cosine squared y. You can do it either way. It won't matter which way you do it. One of them you may prefer to the other. But now you look over here. The cosine of this triangle here is a over the square root of a squared plus x squared. So the cosine is a over the square root of a squared plus x squared. And now we're going to plug in that into our equation here. So we're going to have 1 over a and a cosine. We plug in. And it's squared because cosine is squared. Now if you look, it actually makes it a little bit easier because your radical disappears because the square root of something squared would just be what's left in the radical. And so we have this a here cancels with one of these a's, and so we end up with, for our derivative, a over a squared plus x squared, which is what you had on your paper from earlier. Now, if you would rather use the secant, then come over here to this triangle, and the secant of angle y would just be the square root of a squared plus x squared over a. And then you can plug that in here to your formula, and you can simplify it if you would like. But I find that plugging in the cosine here and then squaring it and simplifying makes it a little bit easier than doing the secant and going from there. But it's really whatever you want to do. And you may not realize it when you're working it on your homework or on your test, and you should get the same answer if you simplify it correctly. So moving on to the cosecant, we're going to start off, instead of y equals cosecant inverse of x over a, we're going to make it the cosecant of angle y equals x over a. And so we're going to draw a right triangle, just like we've done every other time. Our angle is y. Now the cosecant is the same thing as the sine of angle y being a over x. So sine would be opposite over hypotenuse. And then this side here is going to be the square root of x squared minus a squared. And so we are going to take the differential of cosecant y. So the differential is going to be negative cosecant y, tangent y, dy, and then 1 over a dx. And so you end up with dy over dx equal to 1 over a times, instead of writing it as 1 over cosecant y, cotangent y, I think it is better to go ahead and do the reciprocal. So we have 1 over a times, I'm going to put the negative out front. Reciprocal of cosecant would be sine of y, and then the reciprocal of cotangent would be tangent of y. So I think it's easier to go ahead and do that, but you don't have to. And then the sine of y over here, opposite over hypotenuse, and the tangent of angle y, opposite over adjacent. And so we're going to replace those down here in our equation. We get negative 1 over a times a over x times a over the square root of x squared minus a squared. And so your a's will cancel, and we have negative a over x times the square root of x squared minus a squared. And so that would be your derivative here. Now, I'm going to show you that you can also use, instead of using the cosecant of y, you can actually change it into the sine of y equals a over x, if you would rather do it that way. And so we already worked with that a little bit, but what we were using earlier was x over a. So it's not going to be the same as just taking the derivative of the sine of y and going from there. So I'm going to write the derivative of sine as cosine, and then with respect to y. Now, a over x is the same thing as a x to the negative 1. And so when you take the derivative of that, you get negative a x to the negative 2, and then we took it with respect to x. So to solve for dy over dx, you actually have negative a over x squared, because x to the negative 2 is the same thing as moving it to the denominator, and then times 1 over cosine of y. And if you look up here at our triangle, the cosine of angle y is the square root of x squared minus a squared over x, the hypotenuse. So if we plug that in here, we have negative a over x squared and then times 1 over the square root of x squared minus a squared over x. And so we can take the second fraction and make it x over the square root of x squared minus a squared. And so one of those x's will cancel, and you end up with negative a over x times the square root of x squared minus a squared. And so you get the same thing as what you have here, but some people prefer to use one way over the other. It's really just a personal preference. But we are not going to go over how to do the other two, but it is basically the same setup. You'll do them in your homework over the next couple of weeks, but it's basically the same setup as one of the four that we've already looked at. All right, so what to memorize? Derivatives of the inverse sine and inverse tangent appear much more frequently, and those are the two that you should memorize. The other four, if they happen to show up on a test, I will give them to you. But if you have sine and tangent, those are the two that you are going to have to know. So if you have a cosine, a secant, a cotangent, or a cosecant, any of those four I would give you. I put them on the board, or I'd write it on your test for you. But these two you will have to memorize because you'll deal with them so frequently. So now what we're going to look at is the derivative of the tangent inverse of cosine of x. And so here, we're basically using the chain rule. And so what we need to do first is look at what is the derivative of just tangent of x over a. So tangent inverse of x over a. The derivative of that is going to be a over x squared plus a squared. So that's the derivative there. So on this one, we have the tangent inverse of cosine x over 1. So our x is actually a cosine of x, and our a is a 1. So we can say 1 for our a, and then plus 1 squared, which is still 1 for our a squared. And then we need to do x squared. Well, x is cosine, so it would be cosine squared x. However, there's one more thing that we have to apply. We have to actually take the derivative of x. So, what is the derivative of cosine of x? Negative sine x. And so our final answer is negative sine x over cosine squared x plus 1. And that would be your derivative. So you use your formula, but then you have to remember to actually take the derivative of this cosine of x right here. And then once you multiply those two together, you can't really simplify it any further than that, so we leave it just like that. So now let's look at this one. Y equals arc sine of 2x. So I always like to write what my derivative will go to, just so I have my formula. I find it helpful. You don't have to do that, but I think it helps a little bit. And so that's the formula that I have there. And so I'm going to have an x of 2x and an a, well, it's over 1, so my a is actually just a 1. So my derivative is going to be 1 over, a is 1, so 1 squared is 1, and then my x is actually a 2x, so 2x squared, it's going to have to square both the 2 and the x to make 4x squared. But then I have to remember to multiply this by something. It's the derivative of 2x. Derivative of 2x is 2. So I'm going to have an answer of 2 over the square root of 1 minus 4x squared. And so this here is your answer. Looking at the next thing, it has us integrate it. Now these, you have to have memorized your inverse derivatives to know what this one looks like. So if you look at the 6 that you wrote down to begin with, which one is a 1 or an a dx or just a dx in the numerator, and then over maybe an a squared plus x squared, but no radical. If you look, you should see that that looks like tangent inverse. And so this integrates to be tangent inverse of x, and it's technically over 1 because our a is over 1. But you really don't need that. That's just tangent inverse of x. Now, what do we have to remember whenever we integrate? A plus c. You definitely don't want to get a 99 on your test instead of a 100 for forgetting that plus c. So you end up with tangent inverse of x plus c. And so that's why you want to memorize sine and tangent, because usually it's going to be one of those two whenever they have you integrated. So those are the ones that you definitely want to memorize. Hopefully that helps you figure out how you deal with the derivatives of inverse trig functions. Your homework, you get to omit number 3 on your problem set, and it is due tomorrow. So y'all make sure to go over those, and then we can go over any questions you have tomorrow.